All right, so you made it through chapter 1, and hopefully you got a nice score on your test. Regardless of how awesome or poorly you did on the chapter 1 test, hopefully more awesome than horrible, your knowledge of chapter 1 won't really affect you for chapter 2. This class is kind of like 4 distinct chapters, and the chapters don't overlap like they do in a traditional algebra course. So almost every single thing that we learned in chapter 1 won't come up again in chapter 2, and if it does come up, I'll mention it again. So chapter 2, the first half of the chapter is on geometry, and hopefully it's friendly-ish. So section 2.1 looks like it's a short section, so I'm thinking it's going to be like a 40-minute kind of lecture, but we'll find out because sometimes I'm just a long talker, so I apologize for that. So most students, even if they don't know the name, the Pythagorean Theorem, they know the formula a squared plus b squared equals c squared. And that's what the Pythagorean Theorem states. And the Pythagorean Theorem relates to triangles, and it relates to triangles that have right angles. So this triangle that's depicted in the drawing here that has 3 sides labeled, it has a side called C, a side called B, and a side called A. This is a right triangle. A right triangle is a triangle that has a 90-degree angle, and this triangle is a right triangle because that angle right here is a 90-degree angle. Often in a right triangle, we make a little right triangle, a little right, I guess, rectangle in the corner that's the right angle. So the Pythagorean theorem would apply to this triangle, but it wouldn't apply to this triangle. This triangle here, the Pythagorean theorem would not apply because none of the angles are right angles. This looks more like an equilateral triangle, and all the angles are 60 degrees. So even if I'd labeled one side A, one side B, and one side C, the formula a squared plus b squared plus c squared won't apply. It won't work. How about that? Is if you take the number a and square it, and take the number b and square it, and take the number c and square it, a squared plus b squared won't equal c squared. If I'm given a right triangle, the Pythagorean theorem will always apply in a right triangle. And if the sides aren't labeled with letters, then it's going to be my job to figure out which side to call A, which side to call B, and which side to call C. There's one side that I don't have any flexibility on, and that's the C. The C is always opposite the right angle. So if you find the right angle and just point to the side opposite the right angle, that side has to be called C. So the side C is always opposite the right angle, absolutely 100% of the time. The sides adjacent to the right angle, so this side right here and this side right here, I call these adjacent because they're touching the right angle. Those sides you have flexibility. The sides adjacent to the right angle, one of the sides is going to be called A, the other side's going to be called C. If I have a choice, I'll name the shorter of the adjacent sides A and the longer of the adjacent sides B, but it really doesn't matter. So when you're going to name the legs of a right triangle, if the legs aren't already named, you have no flexibility in C. You find the right angle, you search across from the right angle, that side has to be called C, and the sides adjacent to the right angle are going to be called A and B, and they really are interchangeable. So when I labeled the 3 sides of this triangle, it wouldn't have been any more or less correct if I named the side going up and down B and the side going horizontal A. So the sides A and B are very interchangeable. You won't get an incorrect answer if you're doing a homework problem ahead of me and you call one side A that I call B. Our numbers will come out to be the same, and we'll be talking about the same sides, but we'll just be giving them different names. So first example, before we get deep into the homework, is to name each of the sides. And so I gave you a right triangle, and I even pointed at what the right angle is. So I have no flexibility. Once I have a right triangle, I look to the side opposite the right angle. This has to be called C. So it has to be the case that C has to equal 5. It might have been nice if I would attach some units to the C, like maybe that's 5 centimeters, but I didn't. And it's okay. Now the A and the B are adjacent to the right angle, and I have flexibility. So if I wanted to be consistent with what I did in the last example, I made the side up and down going A, so maybe I'll call the A 4, and the side going horizontally B, and call the B C. So this would be a correct answer to how to name the 3 sides of this triangle, but it would be equally correct if I said C was 5, A was 3, and B was 4. And maybe it's even more correct, because if I have the ability to label the sides, I usually make the shorter length A and the longer of the adjacent sides B, but quite honestly, it really doesn't matter. So if I'm just asked to name the sides in a right triangle, I find the right angle, opposite the right angle is the C, the other sides adjacent to the right angle are interchangeable for the A and the B. Now we need to find a missing side, and now I put some units in, so my answer is going to have units. And usually when we're doing geometry type problems, if the original problem has units, my answer should have units. And I was asked in my instructions here to find the missing side and round it to 2 decimals. We're going to have to take square roots in this section to find some of the sides. And in intermediate algebra, you sometimes wrote square roots and you reduced them. For instance, you might have remembered that the square root of 18 reduces to 3 times the square root of 2. In our class, we'll give a decimal reduction for the square root. So whatever the square root of 18 comes out as a decimal, if this happened to be a number that I need, I'm content at this point to just do a decimal version of a square root. And because most of us are using this calculator, to activate a square root on this calculator, let me hit this clear button to clear out anything that's on the main screen. To activate a square root, I hit the blue second button, and then I hit the x squared key, because right above the x squared key in blue, you can barely see it there, there's a square root. And so if I hit the second key, then the x squared key, my calculator would give me a square root symbol and then a parentheses. I'll type the number I want to take the square root of. It would be nice if I close the parentheses by using the right parentheses key, but if I don't, it doesn't matter. And then I hit enter, which is in the bottom row of the calculator. And when I hit enter, my calculator tells me what the square root is. So we're going to need to use our calculator to do square roots unless you do them in your head. So for this side, for this particular example, if I want to find the length of the missing side, it's a right triangle. The right angle isn't denoted, but I'm assuming that this angle right here is the right angle, so that the unknown side has to be a C, and it's interchangeable as to what I call A and B. So I could call the A the 2 and the B the 4, or I could call A the 4 and the B the 4. There's a typo here. It should be I'll pick A. I'll fix that in a second. So what am I going to pick? Well, I'm going to pick A equal to 2 and B equal to 4. And what am I going to do with those numbers? I'm going to put them in the formula. The formula is A squared plus B squared equals C squared. I'm going to not put my units in because it makes the algebra icky to do. What I'm going to do is put my units in at the end. The length of this side has to have the same units as the lengths of the other sides of the triangle. So I'm finding the length of the unknown side, and it has to be in centimeters. So for my problem, for A squared, I'm going to put 2 squared. For B squared, I'm going to put 4 squared. And C squared, I'm going to leave C squared. On the left-hand side, orders of operations require me to do exponents first. 2 squared is 4. 4 squared is 16. So I get 4 plus 16 equals c squared. I forgot to press the record button, so I went and checked it because I was like, ugh, but I had to do the whole lecture over. But I don't, I pressed it. So now I have the left side, the beginning of simplifying the left side. Now I'm going to add the 4 and the 16 to get 20 equals to c squared. And in intermediate algebra, when you solve by square roots, you always need to introduce a plus or minus the square root. But for us, because the length that we're finding is a physical length, the negative is not going to make sense. So I'm going to take the square root of both sides, and I'm not going to worry about plus or minus the square root because the number that I'm finding is a length, and length could only be positive. The left side, the square root of 20, I'll do on my calculator. To do a square root on my calculator, I hit the second button, then the x squared key, and then I type the number I'm taking the square root of, which is 20. Whether I close the parentheses or not doesn't matter. So I'm not even going to close the parentheses. I don't need it. And I'm going to round this to 2 decimals, which is going to be 4.47. I look at the number in the third decimal place, which is a 2. If that number 2 was 5 or bigger, I would have made it 4.48. So like if this was 4.476, I'd write 4.48 as a 2 decimal rounding. But since the number in the third decimal position is less than 5, I don't round the 7, I leave the 7. So that's simplifying the left side. And then on the right side, when you square root something that's a perfect square, the square rooting cancels out the square, and it leaves you just what was being squared. So that gives me 4.47 equals to c. And then for my answer, I'm going to say c equals 4.47 centimeters. And I probably don't really need the c in my answer because the original side wasn't named c. I chose to call it c. But it feels good to use it because it is a C. Because in a right triangle, the side opposite the right angle is always called C. So look at this, exactly how I wrote the answer when I typed it up. So hopefully you're able to see everything you needed to see there. All my work is kind of condensed there. And the stuff that I have typed up here that I didn't specifically go through are all the words that I use. You know, sometimes I really dislike when teachers teach straight from a book because they just read and they don't teach. And this is all the stuff that's typed up I'm going to wind up saying either exactly or basically the same. It's just if you wanted to learn this without watching the video, you can just read through what I have written. All right, so that was that example. And there's the work. And I showed a little less work when I did it I didn't show that I took the square root of both sides, but I did. And square rooting a square, you cancel out the square root symbol, cancels out the square, it leaves you with something that was being squared. Okay, so another example. Find the length, make sure to use proper units in my answer. Because I'm finding a length, my answer is going to have the units of that length, which are centimeters. And in this problem, it's a right triangle again. The side opposite the right angle has to be called C. So my C is going to be 20. It's technically 20 centimeters. I'm going to hold off on the units until I write my answer. And then for the A and the B, it doesn't matter which I call A and which I call B, but one of these two sides needs to be an A and another one called a B. And in my work below, I called this side A. So I'm going to leave it at A, which means this side must be B. So I'm going to use the formula, the Pythagorean theorem that applies to right triangles, that a squared plus b squared equals c squared. And in place of the letter A, I'm going to put the number 12. Again, I could put the units in, but it's just going to make my work messy. In place of the number B, or the letter B, I'm going to put an X because that's what that side's labeled. And in place of the C, I'm going to put a 20. So I could use my calculator if I don't know how to do squares in my head. So to do 12 squared on my calculator, I type the number 12, and then I hit the x squared key. The x squared key is right, the 1, 2, 3, 4, 5th key down, and then I hit the enter button in the bottom of my calculator. So after I have 12 squared, I hit enter, and my calculator would tell me that that's 144. So this gives me 144 plus x squared on the right side, left side. The right side, 20 squared is 400. You can do that on your calculator if you don't know it. You're allowed to use a calculator on every test. So in this case, I need to subtract before I square root. So I'm going to subtract 144 from both sides. On the left side, the 144s are going to cancel. I'm going to have an x squared. And on the right side, I have 400 minus 144, which is 256. And now to get x, I have to square root it. So I'm going to go the square root of x squared equals the square root of 256. On the left side, square rooting cancels out the square, and it leaves me the thing that was being squared. And on the right side, I know that that's 16, but just in case you don't, to do the square root on the right side, I hit the second button, which is the blue button in the upper left-hand corner, and then I hit the x squared key, and then I type the number that I'm square rooting, and then I hit enter. That's in the bottom right-hand part of my calculator. I don't need to close the parentheses. My calculator's not that picky. So I get x equals 16. And again, because the sides of the triangles have units and because we're working in a geometry section, I'm going to attach those units back to my answer. And lengths never have squares or cubes. The lengths is going to, in this case, going to be 16, and it's going to be centimeters. And if you've looked at my work that's on this sheet already, it's exactly the same work that I showed. I get exactly the same answer. Again, this type stuff, I'm eventually going to wind up writing most of it, and you can read through this if you don't want to watch the videos. Okay, in the next example, I'm given a right triangle that's oriented a little bit different. And the sides are in meters. The m is in meters, and I told to round to 2 decimals. So I'm going to label my sides. The side opposite the right angle has to be the c. So my c is going to be 6.2 meters. And the a's and the b's are interchangeable. I wind up calling this an a. So I'm going to call a equal to 4.9. And this side, the x, I'm going to call equal to my b. So in the formula now, for right triangles to find the sides, I'm going to use a squared plus b squared equals c squared. In place of the a, I'm going to put the number 4.9, and I'm going to square it. In place of the b, I'm going to put the letter x, and I'm going to square it. And in place of the c, I'm going to put the number 6.2, and I'm going to square it. I'm going to use my calculator to do both the squares. So I'm going to do 4.9 squared on the left side and get 2,401. I'm going to leave the plus x squared equals, and on the right side I'll do 6.2 squared. That's not 4, I've messed up on the 4.9 squared. I'm going to have to get a decimal in there. 6.2 squared is 38.44. I didn't do 4.9 squared, I did 49 squared. So let me redo that. 4.9 x squared equals, it's 24.01. So the left side of my equation should say 24.01 plus x squared equals 38.44. Now I'm going to minus 24.01 from both sides. On the left side, the 24.01 is going to cancel. I'll be left with an x squared. So that's going to give me x squared equals 38.44 minus 24.01. So I get x squared equals 14.43. Then I'll do the square root of x squared equals the square root of 14.43. On the left side, square rooting cancels out a square. The left side's going to become x. And the right side, to do the square root, I'm going to do second and x squared to get the square root activated. Then I type 14.43. And then I need to round. And this is tricky rounding, so I'm going to actually show it to you. So to round to 2 decimals, I have to decide whether I'm rounding that 9 up or leaving it at a 9. So I look at the number in the 3rd decimal place. That tells me to round the 9 up. The 9, when I round it up, it rounds up to a 10. And I have to carry the 1 over to the 7 and round it up to an 8. So 3.798 rounded is going to be 3.80 or just 3.8. You don't have to write a 0 in the 2nd decimal place. It's not necessary, but I certainly do need units in my answer. Since the lengths of this triangle are in meters, for any version of the answer that I have, I should attach the m to the answer. So whether you give me the 2 decimals with the 0, or if you just give me the 1 decimal because the second decimal is 0, your answer should have the meters. And the work that I showed in my handout is essentially exactly the same thing. I didn't really explain the rounding, I did the rounding. And your work can look just like this, or it can work just like mine. This has a little more detail in it, but they're the same, they're equal to each other. This one's a little harder to read. Let me blow it up a little bit. So this says to find x. There's 2 x's, but they're going to be equal to each other. So this problem is really a Pythagorean theorem problem because there are really, this diagram is really 2 triangles on top of each other. So the 2 triangles that are implied by this diagram is one triangle that I'm writing in black. I'm trying not to draw on that line. And another triangle that I'll show in green. So this problem, Pythagorean theorem doesn't apply to rectangles, it applies to triangles. And in this problem, there are 2 triangles that are implied, and the triangles I drew a little bit bigger right under the drawing. So this is a Pythagorean theorem problem because there's 2 triangles, and both triangles, the hypotenuse is 10, because in the left triangle, which is the triangle you get from the bottom triangle in that rectangle, the opposite the right angle is the C, and in the upside down triangle, the right angle is in the upper right hand corner, and in that triangle, the 10 is the C as well. So what I need to do is break that rectangle up into 2 triangles. Both triangles have the same sides, and I only need to work with one of the triangles to get my answer. So now I'm going to try to get my answer by labeling the sides A, B, and C. The C in both triangles is going to be the 10, and in either triangle I can call the x side A or call it B, and the 8 side I can call it A or B. Those are interchangeable, but I'm going to use A equal to x, B equal to 8, C equal to 10. You could use A equal to 8, B equal to x, C equal to 10, and you'll get the same answer for x. So now I'm going to use the formula A squared plus B squared equals C squared. In for A, I'm going to put the letter x, so I'm going to write in x squared. And for B, I'm going to put the number 8. I'm going to hold off to the units until I get to my answer. And then for the C, I'm going to put the number 10. So the only difference you could have in this is your right side, left side could say 8 squared plus x squared. Regardless of the 2 triangles, which of the 2 triangles that you'd use that are inside this that make up this rectangle, you're going to get the same formula, other than the x and the 8 can be in different positions. So now 8 squared is 8 times 8, which is 64. 10 squared is 10 times 10, which is 100. So I'm going to minus 64 from both sides. That'll leave me with x squared on the left side equals to 36 on the right side. And then I'll go square root of x squared equals the square root of 36. The square root of x squared is just x. The square root of 36 is 6. So I'm ready to write my answer as to what x is. And I need to attach units because in the original rectangle, all the sides have units that are in centimeters. I'm going to write my answer with the centimeters next to it. The work on the next page is just going to be exactly this work. And you'll notice that I did it slightly different. Instead of having x squared plus 8 squared, my work has 8 squared plus x squared, which is kind of nice because it is completely flexible as to which side I label A and which side I label B. And if you label your A and your B differently, your math will look kind of the same but different, because I have 8 squared plus x squared, I have x squared plus 8 squared. But even though the math starts off looking different, it's going to wind up being exactly the same in terms of the answer. And then I always throw units in a geometry answer. Okay, find the height of a triangle. A height of a triangle usually is denoted with the letter h. And this triangle, So that h isn't supposed to be a leg of the triangle. So this triangle looks like this, and this height usually is drawn with a dashed line to represent it's just interior to the triangle. And what you can do to this diagram is you could break it up into two triangles. The two triangles that are inside the one big triangle are this left triangle that I'll draw in black and this right triangle that I'll draw in green. And I drew them below. So here's the left triangle and there's the right triangle. And they both are going to have the same three sides, but the right triangle is labeled much better for me. I'm going to use the right triangle to figure out what the height is. The left triangle doesn't have the hypotenuse labeled. I'm assuming it's 8, but I'm going to work with this triangle. And in this triangle, this angle right here is the right angle, so the side opposite the right angle needs to be the C. So my C is going to be 8. And these two sides are interchangeable for A and B. I'm going to make the A equal to 4, and I'm going to make the B equal to H. Then I'm going to use the formula A squared plus B squared equals C squared. In place of the A, I'm going to put the number 4. In place of the B, I'm going to put the letter H. And in place of C, I'm going to put the number 8. So I get 4 squared for A squared plus H squared for B squared equals 8 squared for C squared. This is going to give me 16 plus H squared equals 64. Now I'm going to minus 16 from both sides. That's going to give me H squared equals to 48. And then I'm going to square root of H squared is going to equal the square root of 48. The square root of H squared is just H. And then I'm going to round to 2 decimals. I'm going to find the square root of 48 on my calculator. So hit the second button and the x squared key, then type the number 48. This gives me 6.928. The number in the third decimal position is bigger than 5, so I'm going to round up. For my answer, I'm going to write 6.93. And I attached the units back. The original triangle, the units of the sides were in feet, so my height, which is one of the sides of the triangle, also needs to be in feet. So my answer to this question, find h, or the height of the triangle, it's going to be 6.93 feet. Hopefully this is feeling like not an overwhelming section. You may have done this all in some other class. And this whole next page is just the math that I just did on the last page. And if you read through that, I did exactly the same thing. I did 4 squared plus h squared equals 8 squared, solved it, square rooted, rounded, put units in my answer. So this page I just talked through on the last page. Now we're ready for the homework. And with all of the homework, I generally like to do the evens while you do the odds. So you can do problem 1. I'm going to do problem 2. My problem 2 is given a little more detail, and yours has the corners of the triangles named. Doesn't matter what names are on the corners. You need to decide what to call the sides. And in a right triangle, the right angle is important because the side opposite the right angle is going to be the C. So when you're doing problem 1, you're solving the unknown side, which is C, and the other two sides you can call an A and a B, and they're interchangeable. So if you called the A12 and the B5, you'll get the same answer for C as if you called the A5 and the B12. Our triangles are remarkably similar, and my sides are labeled, so they're real easy. So I'm going to call A equal to 12 centimeters, B equal to 5 centimeters, and C is going to be the unknown side. And I'm going to use the formula A squared plus B squared equals C squared, and I'm going to go 12 squared plus 5 squared equals C squared. If you need your calculator, pull it out. 12 squared is 144, 5 squared is 25, so this gives me 144 plus 25 equals C squared. I'm going to add the numbers on the left-hand side. That's going to give me 169 equals to c squared. Then I'm going to square root. Square root of 169 is going to be the square root of c squared. Use your calculator. If you don't know, the square root of 169 is 13. On the right side, the squared gets canceled out by the square root symbol, and you're left with c. So my answer for number 2, the missing side, I'm going to call it c, is 13, and I need units. The sides of this triangle are in centimeters, so I'm going to say it's 13 centimeters. You get the same answer for number 1, because it's essentially the same triangle. Okay, 3 and 4, same style. They're a little bit different, but they're both giving you a C and wanting to find the other side, one of the A's or B's. So this side for me, it's opposite the right angle. It has to be a C. So for my problem 4, I'm going to write C equal to 60. The other sides are interchangeable, and it really doesn't matter. I'm going to make an A equal to 48 and a B equal to this X. And you, on your triangle, when you do number 3, the C has to be 53. The other A's and B's are interchangeable. So for my A squared plus B squared equals C squared, I'm going to do 48 squared plus X squared, because this side is called X, equals to 60 squared. And break out my calculator now. 48x squared is 2,304. So this is going to give me 2,304 plus x squared, and 60 squared is 3,600. But a minus 2,304 from both sides. $3,600 minus 2,304 is 1,296. So this gives me x squared equals to 1,296. Then I'm going to do square root of x squared equals the square root of 1,296. The square root of x squared is just x, and then the square root of 1,296 is 36. I'd round it 2 decimals if it needed 2 decimals worth of rounding, because that's what the instructions say at the beginning of the problems. But it doesn't need rounding. So for my answer, I'm going to write x equals, because I'm solving for x, the side's called x, and I'm going to put centimeters onto my answer. So my answer for number 4, I like including the name of the side, which is x, the length of the side, which is 36, and the units for this triangle are centimeters. So my answer for 4 should be x is 36 centimeters. Your answer should be x equals to something, and you might have a 2 decimal answer. I sense that yours, when you get to your square root, you're going to need to do a bit of rounding. Okay, 5 and 6, same. Well, we're both looking for A. So the side, the unknown side, is labeled A. The side across from the right angle has to be the C, and the other of the unknown side must be B, because I'm labeled, the one of them is already labeled A. So for me, I'm going to go use the formula A squared plus B squared equals C squared. I'm going to leave the A as an A. In for the B, I'm going to put a 4.2. And in for the C, I'm going to put an 8.5. And again, I throw my units in at the end. So I need to know what 4.2 squared is. And 4.2 squared is 17.64. So this is going to give me A squared plus 17.64. And then 8.5 squared, which is 72.25. I'm going to need a minus 17.64 from both sides. And I'm using my calculator heavily. Even if I think I could do it without my calculator, it seems kind of silly, because I'd probably make way more mistakes trying to do this by hand. So this leads me to A squared on the left side is 54.61 on the right side. And then I'm going to do square root of 8 squared equals the square root of 54.61. I don't need plus or minus, because the sides of the triangle are always positive. Now I need to go second square root of 54.61, and I'm going to get A, and then 3 decimals, it's 7.389. I'm assuming the problem said to round to 2 decimals, so I'm going to round this 8 up to a 9, and for my answer, I'm going to put the units back in after it's rounded. I'm going to say A is 7.39 and my lengths are in centimeters. Your answer should have inches because the length of your triangle is in inches. So hopefully these are just even things that you knew how to do at one point and they're coming back really quickly. I kind of at least hope that's the case. Okay, find the diagonal of, and mine's a mess because mine has two diagonals. You're looking for this, and just like I did in the problem that was kind of a homeworky problem, you could make this into two triangles, and you only need one of the two triangles. So this triangle right here, which is supposed to go right down this diagonal, might be the triangle that you look at. So my diagonals are, I have two diagonals. Diagonals in a rectangle are equal to each other. I'm going to use this triangle. So I need from my rectangle to get a triangle out of it. I'm going to use this triangle. I suggest that you use this one, but you could use this one as well. Your sides are 10 by 10. My sides are 8 by 15. Mine are a little bit, no, mine aren't any nicer. So for me, the diagonal is opposite the right angle because there's a right angle. So I'm going to call that side C. And then the other sides I need to call an A and a B. Let me call the 8 centimeters my A and the 15 centimeters my B. For you, your sides are going to be A and a B, and it's not going to matter because they're both 10, but you're still solving for C. C is the diagonal in a rectangle. So now I'm going to take the numbers A, B, and C and plug them into the formula. So for A squared, I'm going to make it an 8 squared. So this is 7 and 8, just in case I clipped that from you. So I'm doing problem 8. And my B squared is going to be 15 squared. And then C squared is C squared. 8 squared is 64. 15 squared is 225. This gives me 289 equals C squared. I think that's 17. I must square root it. So I'll do second square root of 289. Mine is easier. It's 17. Yours is going to have a decimal that you're going to need to round. So I'm going to go square root of 289 equals the square root of C squared, which gives me 17 equals to C. For my answer, C is an appropriate name, or I could say the diagonal. So for my answer, if I said C equals 17 cm, that would be fine. And because the question was worded to find the diagonal, if I wrote the diagonal equals 17 centimeters, that's probably better than saying C equals 17 centimeters, but both are fine. As long as you get the right number for the side that we're finding, I'm completely content with whether you call it C or call it diagonal. Same question. So I need to make a triangle up. You can make a triangle up. So we're doing 9 and 10. I'm going to use this triangle. This is the right angle, so this is the C. And then I'm going to make this side an A and this side a B. I don't know if I'm being consistent or not, but it really doesn't matter. So now I'm going to use the formula A squared plus B squared equals C squared. I'm going to go 30 squared plus 40 squared. Now that side is called X, so I'm going to call it X. And 30 squared is 900. 40 squared is 1600. This gives me 2500 equals X squared. Then I'll do the square root of 2500 equals the square root of X squared. And I think that gives me 50 equals to X. But before I commit to writing that down, I'll do second square root 2500 and I get 50. So for my answer to number 10, I can say X equals 50 and then tack on the units, yards. Or I can say the diagonal, because it asked me to find the diagonal, is 50 yards. Those are both equivalently good answer. And so when you go to write your answer for problem 9, you can say X equals to however many meters it comes out to be, or you can say the diagonal equals how many meters. your problem says solve for x in number 11. Mine says solve for the height of the triangle. This I'm calling the height h. Yours is x. I'm going to find this side, and I need to get a triangle out of this. I'm going to use this triangle. For your triangle, you're going to have to assume that the length along the bottom, when you make this two triangles into one triangle, you're going to have to assume that this bottom length is 5, that this 10 is the length of the whole way across, and then this is halfway. So the triangle you're going to need is going to look like that. For my triangle, the right angle is right here, so the C is the 5, and the A and the B are interchangeable. I'm going to call the A this 3 and the B my H. I'll take those numbers, plug them into the a squared plus b squared equal to c squared. So I'm going to go a squared plus b squared equal to c squared. For yours, it says the units are in meters. Let me add that to mine because it doesn't give me a length. I'm going to say assume, just to be consistent with yours, the units are in meters. So when I find these problems on Google Images, because I have a hard time making these drawings, they all don't always have everything I want them to have. And if they're missing units and I want them to have units, I make a little comment about that. And I'll put meters in my answer, which is abbreviated with an M. So now A is 3, so I'm going to go 3 squared. B is H, which is a height. You're going to call X for yours. And C is 5. So this is going to be 9 plus H squared equals to 25. And then minus 9 gives me H squared equals to 16. The square root of H squared equals the square root of 16. So for me, H is going to be 4. And my answer, I'm going to attach meters to it. So for number 12, my answer, it says find the height. You can write X for yours, but I'm going to write height for mine because that's what I'm asked to find. And I'm going to attach units because in the instructions of yours, I'll add that to the instructions of mine. I want to put the units in. So with that, and I could just say H equal to 4 meters. On yours, you could, when it's going to come out to, I'm not sure what it's going to come out to. It's something that's going to have a decimal, I guess. For yours, you're going to have to write, yours is, I don't know what yours is. Yours, you're going to write, you can write X equal, you could write the height equal as well. But since it says solve for X, probably writing X in your answer is best. 13 and 14 are nasty problems. Find the length of the dashed lines. In order to find the length of the dashed lines, I'm going to do the lower dashed line, which is the lower diagonal, that's why it's a small d on yours, and the upper dashed line, which is the upper diagonal, which is a d on mine. So what I'm going to do is look at the bottom of this, and I'm going to make it look like yours. So what I have here on the bottom is I have this triangle that's supposed to have a right angle, because in a box, the bottom is, you're assuming it's a right angle, and my sides are 3 and 4, and then this little dash in yours, the units are in feet. Let me add that to mine. Assume the units are in feet to be consistent with yours. So the triangle that I'm working with, that I stole from the bottom of this, it almost doesn't look like it's a right angle, but this is where the right angle is supposed to be. The sides of a box form a right angle. It's just that you get a little different, when you try to get a 3D drawing, the perspective gets a little bit off. So this triangle along the bottom, which is supposed to be like your triangle, when you go to do yours, your triangle is going to have a 9 feet, a 9 feet, and a D. That's the bottom triangle kind of taken out and blown up. So let's find the D for the bottom triangles. Mine's going to be 3 squared plus 4 squared equals D squared, because the D is opposite the right angle. It's the C. So this is going to give me 9 plus 16 equals D squared. This is going to be 25 equals D squared. So you get the square root of 25 equals the square root of D squared. So 5 equals to D. And in my answer, I'm going to say 5 equals to little d, and I'm going to make it feet, or 5 with a dash feet equals to little d, just so that's how your answer should look. And now I'm going to attack the big triangle. So you should be done now with your little triangle. Your big triangle is this triangle. And in your big triangle, one of the sides is 9, and this is supposed to be a right angle right here. It hardly looks like a right angle. Again, you get this whole perspective thing, but this is supposed to be a right angle, and this is the big D, and the little d that you just figured out, whatever that answer is going to go there. So for my big triangle, my big triangle looks, like that. This is supposed to be the right angle. This side right here is supposed to be 12, and the little side down here is this little d, which is 5, and then this is my big D that I'm trying to find. So for my big triangle, which I kind of sketched out your big triangle, we'll attack this, and I'm going to go, that's going to be a C. So for my big triangle and my big D, I'm going to go 5 squared, which is that side, plus 12 squared, which is a B or an A, equals D squared, which is definitely a C because it's across the right angle. So mine's going to be 25 plus 144 equals D squared. So I get 169 equals to D squared. Then I do the square root of 169 equals the square root of D squared. So 13 equals to D. I'm going to attach the unit of feet next to it. And so my answer for problem 14 is the length of the dashes I call the bottom dash little d, which is 5 feet, and the bigger dash big D, which is 13 feet. Alright, so that's that. I think the next problem is just about the same. And I think that's about the end. I'm running out of paper here, but it is actually the last 2 problems. So on yours, in this problem, the C that you need to find in problem 15 is the one that you have to find first. So in your problem 15, the triangle along the bottom of this is supposed to have a right angle. Again, it gets distorted when you do these 3D drawings. So your C is going to come from this triangle, and then your D is going to come from, and look how the right angle is even drawn in there so nicely. Your big triangle is going to have a 10, a D, and whatever this answer for C is. So these are the 2 triangles you're going to have to do in problem 15. I have a harder one because my big triangle is going to be this. The triangle I'm going to need to solve for the D is that triangle, and this side is going to be 12 inches because it's mirrored those. But in order to get this side D, I need to get something I'll call C. I'll make it like your triangle, and I'm going to draw a bottom triangle that has a right angle in it, and this is a C. So I'm going to do my little triangle. It's going to have on the bottom, there's an 8-inch side, a 10-inch side, and then a C. And then my big triangle has a 12-inch side, the C side, and then the D. And I'll solve for both C and D. I'll make mine more like yours. So back this out so you can see this. So here I'm going to go 10 squared plus 8 squared equals C squared. This gives me 100 plus 64 equals C squared. So 164 equals C squared. And I'm just going to square root that. So I'm going to go second square root of 164, which gives me 12.81 rounded. So I get the square root of 164 equals the square root of C squared. gives me 12.81 equals to C. I'm going to use that rounded answer. It's probably not best to use a rounded answer, but I'm going to live with it. So in my problem, it doesn't ask me to find a C. I created a C to be like your problem. And my C is going to be 12.81 inches because the units in the problem are inches. Now for the next triangle that I created that had one of the sides D, the other side 12, and the other side C, I'm going to change the C to 12.81. And I'm going to use the Pythagorean Theorem. I'm being a little bit careless because I'm hoping you get good. These sides are my A's and my B's, and hopefully you start getting a little more comfortable with these. So I'm going to go 12 squared plus 12.81 squared equals D squared. The D is opposite the right angle, so it's the hypotenuse. 12 squared is 144, and 12.81 squared is 164.06. I'll round that to 2 decimals just because that's what I've been doing. So that's 164.10 because it's 9. That 6 rounds the 9 to a 10, and the 1 carries over. So I get 144 plus 164.1 for the left side. That gives me 308.1 equals D squared. And then I'm going to square root of 308.1 equals the square root of D squared. And now second square root 308.1 gives me 17.55 equals to D. And so I probably did things that were bad in terms of rounding early. Every time I take a decimal that has more than 2 decimals and I round it, if I use a rounded number in my work, it's going to make my answer slightly less accurate. But if I'm consistent with myself, and because we're not using these numbers for anything but to solve the problem, and that's like I'm building a box and I need to make the diagonal exactly the right length, the lengths, I have a little freedom to fudge a little bit. So I feel okay about rounding C to 2 decimals, using the rounded C in my answer, and then 12.81 squared using a rounded version of it. If you didn't round answers or you carried more decimals, you'd get a more accurate answer in terms of decimals, but it's not going to be remarkably different. And if we're just consistent with our methodology, our answers will all come out the same. So anytime we pick up a decimal in this section, 2.1 on the Pythagorean Theorem, I'm just going to round it to 2 decimals and just use a 2 decimal answer. So hopefully these 3D problems weren't too overwhelming. If they didn't feel good, come visit me, shoot me an email, or bring a question to class, and I'll attempt to do some. I probably can't draw these pictures too terribly well, so I'll have to, you'll watch me draw it. It'll be really a treat, or embarrassing for me and fun for you, I guess. So that's the whole section. I think it was shortish, so hopefully you feel good about it. There should be a lot of review in Chapter 2. Chapter 2, the first half of the chapter is on geometry, and most of what we've see in Chapter 2 you may have seen in a high school class, or if you have kids with